In this segment, we are going to talk about elements and compounds. So these ones are elements, these ones are compounds. As you will see later, these elements will give them the name molecule. I don't know why the book gave them this name, but I'm sure that that's what you are going to be using with your teacher. So I'm going to use that, although it's not a correct name. Now, let's look at these two, an element and a compound. I'll give you examples. So, examples for element, we have oxygen element or oxygen molecule, we have nitrogen molecule, we have chlorine molecule, we have iodine molecule, we have sulfur molecule, and we have a bromine molecule, we have fluorine molecule, among other things. All these are known as elements or molecules. Why do we call them like that? An element has one type of atoms. So you need to take note of that. Element has one type of atoms. As you can see, oxygen has two atoms that are both oxygen. Nitrogen has two atoms that are both nitrogen. Sulfur has 8 atoms. All of them are S. What about the compounds? Examples of compounds: we have water, we have carbon dioxide, we have sulfur dioxide, we have nitrogen monoxide, we have methane, we have nitrogen dioxide, among others. So compounds, all these are compounds. Compounds form from two or more atoms, or let me write it properly. So I'll say compounds form when atoms from two or more different elements combine. So here you can see that in water we have H combining with O. In carbon dioxide we have C combining with O. In sulfur dioxide we have S combining with O. In methane we have C combining with H. So when atoms from different elements combine to form one substance, that substance, we call it a compound. So here, the molecule here is like an element. So the definition of a molecule is the smallest particle of matter that can have independent existence. So keep that definition. Definitely you'll be asked about that definition on your exam. But here we say that molecules usually form when two or more atoms bond together by forming a covalent bond. So we'll talk about what this covalent bond is. For example, here, oxygen. Oxygen, we write it this way. So here, in between them, we have a covalent bond. But we'll talk about that. So a molecule is the smallest particle of matter that can have independent existence. So these are the examples of molecules, or they were. Within the molecules that we have this, all the way to this. These ones are elements. So both of them are molecules. Now this, and this. All of these are compounds. So a molecule comprises both elements and compounds. Here they are defining a molecule also as an element, but really both elements and compounds comprise a molecule. So we are saying that compounds form when two or more different elements bond together. So about compounds, the elements that we have must be different. That's the key. So to form a compound, we must have different elements that bond together. And this is an example of a compound. That is water. Normally, these elements and compounds form through chemical reactions. So when we talk about the chemical reactions, normally a chemical reaction will release energy or absorb energy. So the chemical reaction that gives off energy is known as exothermic. So take note of this. A chemical reaction that gives off energy is known as exothermic. A chemical reaction that absorbs energy or that takes in energy is known as endothermic. So please write down the definitions for these. Exothermic gives off energy. Endothermic absorbs energy. So let's talk about now these chemical bonds. What does a chemical bond mean? So a chemical bond is an interaction between atoms. So there is interaction between atoms to form a stable substance through one sharing of electrons. 2, transfer of electrons. 3, SC of let me just rewrite the third one. So we said forms through sharing electrons, through transfer of electrons, and through interaction between like a sea of electrons in a positive environment. So a chemical bond is the interaction between atoms to form a stable substance through 1, sharing of electrons, 2, transfer of electrons, 3, a sea of electrons within positive islands. But really, this is number 3. This number 3, we don't focus much on it. So you are not going to focus much on this one. But we are going to focus on this, the 1 and 2. So for now, ignore the chemical bond number 3. So what is this? We have 3 types of chemical bonds, as you can see here. 1, 2, 3. A bond that forms through transfer of electrons. A bond that forms through transfer of electrons is known as ionic bond. A bond that forms through sharing of electrons is known as covalent bond. So these are the bonds that we are going to focus. The third bond that is there is known as metallic bond, but we are not going to talk about metallic bond. So it's just these 2 chemical bonds. So this is covalent bond. And take note how we are mentioning it, covalent bond. So to form ionic bond, you need to have ions. So if you have to form an ionic bond, you need to have ions. So what are these ions? Ions are just charged particles that form when electrons are transferred from one atom to another. For example, you may have sodium here, which is a solid. So a solid, and this sodium loses an electron. When the sodium loses an electron, it forms sodium ion. So this is sodium ion, while this one is sodium atom. So the atom is uncharged, while the ion is charged. That's the difference between the two. The atom is uncharged, the ion is charged. So when two ions combine, they form a covalent compound. Not covalent, but ionic compound. So when two ions combines, when two ions combine through chemical bond, they form an ionic bond, and whatever they form is an ionic compound because it's a compound formed from ionic bonds. So I'll just put this in parentheses, ionic compounds. So for them to form, you need two ions. Two ions that are opposite, that are going to attract. For example, here, if I have two ions like sodium, which is positive, and chlorine, which is negative, if I add them, they will form an ionic compound, which is sodium chloride. So this one is an ionic compound. And we'll see how this ionic compound forms. So, how does it work? This is sodium atom. So sodium atom has 2 electrons inside and 8 electrons in the middle and 1 electron outside. This is chlorine atom. Chlorine atom has 2 electrons inside, 8 electrons in the middle, and 7 electrons outside. So we'll say chlorine has 2, 8, then 7 electrons, while the sodium has 2 inside, 8 in the middle, and 1 outside. But by octet rule, sodium will want to have 8 electrons in the outer shell. The same thing, chlorine will want to have 8 electrons in the outer shell. So both molecules, both atoms, that is, both atoms need 8 electrons in the outer shell to be stable. So if sodium has to be stable, it needs 8 electrons in the outer shell. If chlorine has to be stable, it also needs 8 electrons in the outer shell. Now, how does sodium get the 8 electrons? There are 2 ways that sodium can get the 8 electrons. It can get the 8 electrons in its outer shell by adding 7 more electrons here, so that in the end we have 8 here. But that would be too much. Where do we get all the 7 electrons? That is one way. Another way, sodium can get 8 electrons by losing this shell, by losing this electron that is here. So if sodium loses this electron, it becomes sodium ion, which has 2 inside here and 8 outside because this electron is gone. Where does this electron go? Out here we have 7 electrons. For chlorine to be stable, it needs 1 more electron. So the electron will transfer from here all the way to here, so that we are going to have an excess of 1 electron for chlorine. Then both of them will be stable. As you can see, because we have lost an electron, each electron is negatively charged. So if you lose 1 electron here, you are losing 1 negative from the energy levels. The total charge will be positive because you have lost 1 negative. While here, this negative that transfers from here goes to here and makes the total charge negative. So what is going to happen is, like we are seeing here, this electron is alone here, so it gets lost and goes to this chlorine. In the end, this one, that what we see here, you can see inside here we have 2, outside here we have 8. So at this point we have reached the octet for sodium. So we reached octet for sodium. Here you can see 2, 2. Now instead of 7 we have 8, which tells us that also we have reached octet for the chlorine. Now this one is positively charged, this one is negatively charged. So we'll be like this plus this minus. When you bring them together, they'll form a compound sodium chloride. This one is ionic compound. So that's how we form an ionic compound, by transfer of electrons from one element to another, so that both the elements become charged. One element becomes positively charged, the other element becomes negatively charged. And the unlike charges will attract each other to form this chemical bond, that is ionic bond. So I mean, we have a lot of examples of ionic bonds, ionic compounds. I can just write them here. So just for example, potassium chloride is an ionic compound. Sodium chloride is an ionic compound. We have magnesium chloride, another ionic compound. Lithium chloride, another ionic compound. Magnesium oxide, another ionic compound. So how do we know this is an ionic compound? If you look at the periodic table, if you go back to look at the periodic table, an ionic compound forms between an atom that is on the left side of the periodic table and an atom that is on the right side of the periodic table. Any atom that is on the left side of a periodic table is called a metal. So I'll just say left side of periodic table has metals. So you need to write this down. Right side of periodic table has non-metals. So the left side has metals, the right side has non-metals. Now, ionic bond forms between a metal and a non-metal. So, ionic bond forms between a metal and a non-metal. What is the reason? Metals lose electrons, non-metals gain electrons. That's the reason. So metals lose electrons. Let me just so take note to write this information down. Metals lose electrons, non-metals gain electrons. Metals lose electrons. Non-metals gain electrons. So that's why we are able to form an ionic compound between the metals on the left side of the periodic table and the non-metals on the right side of the periodic table. So if you have questions on this, just ask me. Then we have another type of chemical bond that we call covalent bond. So in this case, the atoms share electrons. So the atoms will share electrons to form a covalent bond. This bond, so covalent bond, forms between non-metals. So it forms on elements on the right side of the periodic table. So elements on the right side of the periodic table, but also it also includes hydrogen. Although hydrogen is not on the right side of the periodic table, it is also a non-metal. So it is involved in covalent bonding. So really, this type of bonding forms by sharing of electrons. There is no transfer of electrons in this case. They just share. But the aim is the same. We want each element in that chemical bond to have 8 electrons in its outer shell, or 2 in case of hydrogen. So what does this mean? Let's take these 2 hydrogen atoms. The maximum electrons for hydrogen is 2. So the maximum electrons that hydrogen can have is 2. Because of that, the octet of hydrogen contains only 2 electrons. So this implies the octet of hydrogen contains only 2 electrons. So if you are forming a chemical bond, a single hydrogen will have 1 electron, and another hydrogen will have 1 electron also. But for hydrogen to have an octet, it needs to have 2. It needs to have a total of 2 electrons. And because of that, there will be sharing. There will be an electron. What is this thing doing? So because of that, the 2 hydrogens will say, you know what? Let us share our electrons. So what's going to happen? This one will say, okay, I'll give you my electrons, and this one will say, okay, I'll give you my electron. In the end, you have H, and they share this electron in between them. This sharing of 2 electrons is known as a chemical bond, but it's a covalent bond. So we can write it like H, a chemical bond there. So that is a covalent bond. Now if you take another element, let's say fluorine. Fluorine has 7 electrons in its outer shell. We can talk about that. And if we have another fluorine also that has 7 electrons in its outer shell. Now these 2 fluorines, so an electron here, an electron here. These 2 fluorines will combine to fulfill the octet. Because in the end, this fluorine needs 8 electrons. This fluorine also needs 8 electrons. So what will happen? This one will share its electron. This one will share this electron. In the end, you have F. You have FF, this shared electron, and then the rest of the. So as you can see, I can count. For this fluorine, due to this sharing, it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. This one, this fluorine, also due to the sharing, it has 1, 2, 3, 4, 5, 6, 7, 8. So each fluorine here has reached the octet by sharing electrons. But how many electrons are shared? It's only this one. So we can say from there, fluorine has formed a single covalent bond by sharing of the electrons. Now if we go to oxygen, oxygen has 6 electrons in its outer shell. And another oxygen here has 6 electrons in its outer shell. So let's count. This oxygen needs 8 electrons, but it only has 6. This oxygen needs 8 electrons, but it only has 6. So what's going to happen? There will be sharing. As you can see here, 1, 2, 3, 4, 5, 6. Then this oxygen will share with this one. So we'll say this oxygen has 1, 2, 3, 4, 5, 6, 7, but it needs one more. What does it do? It will take also from here. Now it has 1, 2, 3, 4, 5, 6, 7, 8. This other oxygen also has 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So both oxygens have 8 electrons. But how did they get 8 electrons? By forming what we call a double bond. So it is still covalent bond, but it is a double covalent bond. So when you talk about chemical bonding, we have single bond, this one. Single bond forms from only 2 electrons. We have double bonds. Double bonds form from 4 electrons. We also have triple bonds. A triple bond will form from 6 electrons. So this one is a double bond. You can see it has formed from 1, 2, 3, 4 electrons. Each single chemical bond is formed by 2 electrons. 1 electron from one atom, the other electron from another atom. So let's see these examples. We have chlorine and chlorine sharing electrons to form a single bond. You can see this single bond has only 2 electrons. We have nitrogen. Nitrogen will share, because this nitrogen has 1, 2, 3, 4, 5 electrons out here, but we need 8, which means we need 3 more electrons. This one has 1, 2, 3, 4, 5 out here. So to reach the octet, it needs 3 more electrons. Where does it get them? It will get them from this other nitrogen. So they will form a chemical bond here, then form another chemical bond between these, and a third chemical bond between these. As you can see, there is sharing of 6 electrons to form a triple bond. So this one is a single bond. This one is a triple bond. The one that we saw with oxygen is a double bond. Oxygen also can combine with hydrogen. Now here oxygen has 6 electrons. It needs 2 more for it to have 8 in its outer shell. Hydrogen has 1 electron. This hydrogen also has 1 electron. So what is going to happen? There will be sharing of electrons. This electron will share with hydrogen will share with that. The other hydrogen will share with that. In the end, oxygen will have 8 electrons. Each hydrogen will have 2 electrons. So they have filled their octet. So I'll stop here and continue later on.